Hello and welcome to this special deep dive report. Today is December 20th, 2025, a date that historians of astronomy will likely circle in red for decades to come. We are standing at a pivotal moment in our understanding of the cosmos. Just 24 hours ago, the object known as 3I Atlas, or C2025N1 to give it its formal designation, made its closest approach to Earth. And now, as we speak, it is already racing away from us, plunging back into the dark, cold void from which it came. But while the physical object is retreating, the data it left behind is crashing into our servers like a tidal wave, and the picture it paints is anything but ordinary. Let's look closer at the data we have right now. As of this morning, 3I Atlas has crossed the 270 million kilometer mark from Earth. To put that in perspective, that is roughly twice the distance between the Earth and the Sun. It is moving at a staggering velocity of 58 kilometers per second. That is not just fast, that is hyperbolic. In orbital mechanics, a hyperbolic trajectory is the signature of an interstellar visitor. It means this object is not bound by the Sun's gravity. It isn't looping back around like Halley's Comet. It is a one-time visitor, a traveler passing through our system on a journey that likely began millions, perhaps billions, of years ago. It will cross Neptune's orbit within the next year and then silence. It will be gone forever. Now, before we go any further into the anomalies that are keeping scientists awake tonight, if you want to stay ahead of this rapidly evolving story and understand the science shaping our future, make sure you hit that subscribe button and turn on notifications. We are tracking this object daily, and you won't want to miss what comes next. The headline news, of course, is that there is no threat. The flyby on December 19th was completely safe. At 168 million miles, it was never on a collision course. But this calm farewell is deceptive. While the trajectory was predictable, the behavior of the object itself has been anything but. Astronomers monitoring the departure are reporting a phenomenon that some are calling a heartbeat. This is not a poetic metaphor. It is a description of a rhythmic, intense fluctuation in brightness and activity that began almost immediately after the comet passed its point of closest approach. Standard comets do not typically behave this way. When a comet approaches the Sun, it heats up. Ice turns to gas, a process called sublimation, and dust is released, creating the glowing coma and the iconic tail. This activity usually scales with proximity to the Sun. It gets brighter as it gets closer and dimmer as it moves away. But 3I Atlas is doing something different. As it moves away from Earth, its activity is intensifying in pulses. It's as if the object is reacting to its environment, or perhaps reacting to its departure. We are seeing rapid brightening events followed by dimming, repeating in a cycle that suggests rotation, but a rotation that is complex and possibly tumbling. This heartbeat signal is strong, distinct, and currently unexplained by simple solar heating models. If this were a standard ball of dirty ice, the outgassing should be smooth and declining. Instead, we are seeing spikes. This contradicts what we previously thought about the stability of interstellar comets. We assumed they would be relatively inert until they got very close to the Sun and then behave predictably. But 3I Atlas is showing us that our models might be too simple. The fluctuations are so precise that some observers initially thought it might be an instrument error. But the data has been corroborated by observatories in Chile, Hawaii, and the orbital telescopes. The signal is real. So, what does this actually mean? A heartbeat in astronomical terms usually implies a rotating body with an active region, a jet or a vent, that sweeps toward Earth like a lighthouse beam. Every time that active spot faces us, we see a spike in brightness. But for the brightness to intensify as it moves away from the heat source, that requires an internal mechanism or a surface composition that is incredibly volatile. It suggests that something on the surface of 3I Atlas is being triggered, not just by the Sun, but perhaps by the gravitational stresses of its flyby, or by internal pressures we don't yet understand. The implications of this are profound. If this object is tumbling and pulsing, it means its internal structure is dynamic. It is not a solid, frozen rock. It might be a loose rubble pile shifting under its own weak gravity. Or it might be a rigid body with specific high-pressure vents. The frequency of these pulses is giving us clues about its density and its shape. And the shape is another puzzle we will get to. But for now, focus on that rhythm. It is the rhythm of a machine or a geological process so alien that it mimics one. We are also seeing that this heartbeat is accompanied by changes in the coma's structure. It's not just getting brighter. The shape of the gas cloud around the nucleus is warping. It's expanding and contracting in sync with these pulses. This suggests that the release of material is explosive, not gradual. It's like a series of detonations going off on the surface. What could cause that? Pockets of exotic ice? Trapped gases from another star system suddenly finding a way out? Or is it something else entirely? As we track 3I Atlas speeding towards the outer solar system, this heartbeat is our primary diagnostic tool. It is the pulse of a patient we can only examine from a distance, and right now that pulse is racing. It tells us that the object is active, volatile, and perhaps fundamentally different from the domestic comets we have studied for centuries. This activity brings us to the question of what exactly is being ejected during these pulses. If it's just water vapor, that's one thing. But the preliminary data suggests the material being thrown out during these heartbeat spikes is chemically complex. We are looking at the blood of this interstellar visitor, and the chemical analysis is about to turn our understanding of planetary formation upside down. The heartbeat is just the symptom. The cause lies in the chemistry. And as we peel back the layers of light coming from 3I Atlas, we are finding ingredients that have no business being there in these quantities. This is where the story shifts from orbital mechanics to astrochemistry, and where the mystery deepens significantly. We have established that the object is pulsing. Now we need to understand what it is pulsing with. The spectroscopic readings taken during the flyby are now being processed, and the initial results are shocking. We are seeing spectral lines that shouldn't be this strong and combinations of elements that are rare in our own solar system's comets. This connects to the broader mystery of where 3I Atlas came from. If it originated in a system like ours, it should look like ours. It should be made of the same stuff, water ice, silicates, simple organics. But the heartbeat is pumping out something else. It is pumping out a chemical cocktail that hints at a very different origin story, perhaps from a star system with a completely different metallicity or a different history of formation. As we move forward in this investigation, keep this heartbeat in mind. It is the metronome setting the pace for the rest of the anomalies we are about to uncover. It is the first clue that 3I Atlas is not going quietly into the night. It is speaking to us in bursts of light and gas, and we are frantically trying to translate the message before it fades. The acceleration we mentioned earlier, that 58 kilometers, is also part of this puzzle. The object isn't just coasting, it's maintaining speed in a way that suggests the outgassing, the very stuff causing the heartbeat, is acting like a thruster. This is known as the non-gravitational effect, where the push of evaporating gas alters the orbit. But for the effect to be this pronounced and linked to this rhythmic pulsing, the jets must be incredibly powerful and focused. We are witnessing a natural engine at work, or at least we assume it is natural. The efficiency of this engine is what has drawn the attention of scientists like Avi Loeb, whom we will discuss later. But even from a purely conservative standpoint, the mechanics of this comet are extraordinary. It is a high-performance object. In the next chapter of this report, we are going to analyze the blood of the comet. We will break down the spectroscopic data that reveals unexpected spikes of carbon dioxide, methanol, and, most baffling of all, nickel. And we will discuss the anti-tail, a feature that defies the solar wind and points the wrong way. The heartbeat was just the beginning. The chemistry is where the impossible becomes undeniable. Stay with us. As we established in our previous report, the interstellar object 3I Atlas is not just passing through, it is pulsing with a rhythmic heartbeat that suggests a volatile and dynamic surface. But to truly understand what this visitor is, we have to look beyond its motion and examine its substance. We have to analyze the blood of the comet. And this is where the scientific consensus begins to fracture, because the chemistry of 3I Atlas is rewriting the rulebook. Let's look closer at the data coming from our spectrometers. Spectroscopy is essentially the science of reading light fingerprints. When sunlight hits the gas cloud, the coma, surrounding the comet, the atoms and molecules inside absorb and emit light at specific frequencies. By spreading that light into a spectrum, we can identify exactly what elements are present. It is a technique we have used on thousands of comets. We know what a comet looks like chemically. Lots of water vapor, some dust, traces of ammonia and methane. But 3I Atlas is different. The spectral readings taken during the December 19th flyby reveal unexpected spikes of carbon dioxide, methanol, and, most baffling of all, nickel. Now, finding carbon dioxide and methanol isn't entirely unheard of, but the quantities are staggering. The ratio of these volatiles to water is far higher than what we see in our local comets. This suggests that 3I Atlas formed in a region of its home star system that was much colder than our own Kuiper belt, a place where these gases could freeze solid in vast quantities. It hints at a chemical cargo from a frozen twilight zone of another galaxy. But the real shocker is the nickel. In our solar system, nickel is almost always found alongside iron. They are cosmic twins, forged together in the hearts of dying stars and distributed together in the dust that forms planets. Where you find one, you find the other. But in the coma of 3I Atlas, we are seeing strong signatures of nickel vapor, but almost no iron. This contradicts what we previously thought about cosmic abundance. How do you separate nickel from iron on a planetary scale? It implies a refining process or a formation history so unique that we don't have a model for it. Some planetary scientists suggest we might be looking at the exposed core of a shattered planetesimal, a chunk of a world that differentiated its metals and was then ripped apart. But even that doesn't fully explain the purity of the nickel signal. It is an anomaly that stands out like a sore thumb in the data. And then there is the anti-tail. If you look at any standard diagram of a comet, the tail always points away from the sun. This is basic physics. The solar wind, a stream of charged particles from the sun, pushes the gas and dust away like a windsock in a gale. But 3I Atlas displays a prominent, narrow stream of material directed toward the sun. This is the anti-tail enigma. Now sometimes an anti-tail is just an optical illusion caused by the Earth crossing the plane of the comet's orbit, making the dust trail appear to point the wrong way due to perspective. But the geometry of the December 19th flyby doesn't support a simple perspective trick. The data suggests a physical stream of material actually moving sunward. So, what does this actually mean? If material is moving toward the sun, it is fighting the solar wind. That requires force. It implies that the particles are either too heavy to be pushed back easily, perhaps large grains of that mysterious nickel, or they are being ejected with significant velocity in that specific direction. Here is the crucial detail. The anti-tail is collimated. That means it's not a spreading fan of dust. It's a narrow, focused beam. In nature, gas expands. To keep a stream of gas or dust narrow over millions of kilometers requires a focusing mechanism. We see this in the jets of black holes or young stars, where magnetic fields confine the flow. But a comet shouldn't have the magnetic power to collimate a jet like this. This brings us to a point where we have to ask a difficult question. If the chemistry is wrong, nickel without iron, and the physics is wrong, a sunward collimated jet, are we looking at a natural object at all? I want to pause here and hear from you. We are looking at a list of impossibilities, a heartbeat rhythm, a missing iron signature, and a tail that points the wrong way. What is your gut telling you? Is this just a weird rock from a weird solar system? Or is there something more to it? Drop a comment below with your theory, natural anomaly, or something else. I'll be reading through them after the broadcast. The presence of methanol is also worth a deeper look. Methanol is a building block of organic chemistry. It's an alcohol, yes, but in space, it's a precursor to life. Finding it in such high abundance supports the idea that comets act as interstellar gardeners. If 3I Atlas is shedding methanol and carbon dioxide across our solar system, it is technically enriching our neighborhood. It is leaving a trail of complex molecules that, under the right conditions, could be part of the recipe for biology. But the combination of these organic markers with the metallic anomaly creates a cognitive dissonance. On one hand, it looks like a seed pod carrying the ingredients for life. On the other, it looks like a refined metallic construct. The duality is confusing. Is it a rock covered in sludge or a machine covered in ice? The anti-tail might be the key to unlocking this. If the object is rotating, remember the heartbeat, and it has a specific vent or nozzle that aligns with the sun at a certain point in its rotation, The ejection could be directed sunward, but for the jet to remain stable and collimated, the nozzle would have to be incredibly precise. A jagged crack in the ice usually produces a messy spray, not a beam. This stability is what caught the eye of Harvard astrophysicist Avi Loeb. He argues that we are trying too hard to fit a square peg into a round hole. We are inventing complex, low-probability natural scenarios to explain away features that would be simple to explain if the object were artificial. The nickel, in his view, isn't a geological oddity. It's a material choice. The anti-tail isn't a perspective trick. It's a thruster or a probe. The heartbeat isn't tumbling. It's a signal or a scan. As we move to the next part of our investigation, we are going to leave the comfortable safety of NASA's conservative models and step into the controversial territory of the technosignature debate. We will examine the 15 specific anomalies that Loeb and his colleagues have identified, anomalies that, when taken together, paint a picture of three-eye atlas that is radically different from a dirty snowball. We have looked at the blood, and it is strange. We have looked at the tail, and it is wrong. Now we have to look at the mind, or the lack thereof, behind the motion. Is three-eye atlas wandering, or is it driving? That is the question we tackle next. Building on this chemical analysis, we can see that the physical evidence is mounting. The pieces of the puzzle are on the table, but they don't form a picture of a comet. They form a question mark. And in the shadow of that question mark, the scientific community is dividing into two camps: those who see a freak of nature and those who see a visitor. Join me in the next file as we break down the artificial hypothesis and see if the math holds up to the scrutiny. The evidence is about to get even stranger. Given what we now understand about the impossible chemistry and the defying physics of the anti-tail, we arrive at the most contentious part of this story. It is the point where data meets imagination and where the scientific community splits down the middle. If Three-Eye Atlas is not a normal comet, what is it? Harvard astrophysicist Avi Loeb has an answer that many are afraid to whisper, but he is shouting it from the rooftops. He suggests that the combination of oddities we are seeing, the heartbeat, the nickel, the collimated jet, could point to an artificial origin. He believes we might be looking at a piece of extraterrestrial technology. This is the technosignature debate. Loeb, known for his bold hypotheses about the first interstellar visitor, Oumuamua, has gone further this time. He has compiled a list of 15 distinct anomalies in the behavior of Three-Eye Atlas that, in his view, do not fit within the framework of a natural cometary object. Let's look closer at the data he is highlighting, because these aren't just minor quirks. They are fundamental contradictions to the standard model. First, consider the orbit. Three-Eye Atlas is on a retrograde orbit. This means it is moving around the Sun in the opposite direction to the planets. While this is possible for captured objects or long-period comets, it is rare. It suggests an entry vector that was completely independent of the swirl of material that formed our solar system. It came from the edge of the Milky Way, dropping in on us from above the galactic plane. Loeb argues that this specific trajectory, which allowed for close flybys of Jupiter, Mars, Venus, and Earth without a collision, hints at a controlled motion. It threaded the needle of our solar system with uncanny precision. Second, there is the nakedness of the object. Despite the heartbeat and the chemical spikes we discussed, 3i Atlas lacks a massive dusty coma. Usually, a comet this active would be surrounded by a huge, fuzzy cloud of dust. But 3i Atlas remains relatively sharp and point-like in telescopes. This implies that the surface isn't shedding dust like a crumbling rock. It's venting gas like a solid shell. The absence of dust supports the idea of a metallic or artificial surface that doesn't erode, but rather outgasses from specific points. Third, and perhaps most telling, is the non-gravitational acceleration we mentioned in the first chapter. The object is speeding up. Natural comets do this when ice sublimates, acting like a weak rocket. But for 3i Atlas, the acceleration is smooth and persistent, even as it moves far away from the Sun, where the heat should be too weak to drive such powerful sublimation. Loeb points out that this behavior is consistent with a light sail, a thin, reflective material pushed by the pressure of sunlight, or an autonomous propulsion system. This is not just a comet. It is a message from another world that we risk missing forever, Loeb said in a recent interview. His words have ignited a firestorm of debate. He speculates that the object could be an ancient probe, a defunct buoy, or a fragment of a larger craft that accidentally entered our system. The heartbeat we see? In this context, it could be a tumbling transmission dish or a rotating section of a derelict hull reflecting sunlight. So, what does this actually mean? If Loeb is right, we are watching a piece of alien garbage or treasure drift past us. The nickel composition makes sense for a manufactured object. Nickel alloys are durable and resistant to the harshness of space. The collimated jet isn't a random vent. It's a thruster firing to adjust course, or a leak from a ruptured tank. But we must be balanced. NASA and the mainstream astronomical community are not ready to jump to aliens. They emphasize that all observations, while weird, are still consistent with extreme cometary characteristics. NASA points to the X-ray flares detected during the flyby. These flares occur when solar wind slams into a cloud of gas. They argue this proves there is a gas cloud, even if it's thin. They also point to the detection of water vapor and carbon monoxide, alongside the exotic chemicals. To them, 3i Atlas is an ancient relic, a pristine sample from the dawn of planetary formation in another star system. It's weird because it's old, perhaps 7 billion years old, predating our own sun. It has been cooked by cosmic rays for eons, altering its surface chemistry in ways we don't yet understand. The official stance is that the anomalies are just gaps in our knowledge of interstellar ice physics, not evidence of engineering. They argue that extraordinary claims require extraordinary evidence, and a few spikes in a spectrum aren't enough to rewrite history. However, even the skeptics admit that the stable collimated jet is hard to explain. A natural jet should wobble and spread. A beam that stays focused over millions of miles is suspicious. It is this specific detail that keeps the artificial hypothesis alive. This connects to the broader question of what we are looking for. If we only look for rocks, we will only find rocks. Loeb argues that we need to be open to the possibility that the universe is littered with the debris of other civilizations. 3i Atlas might be our version of a message in a bottle, washing up on our shores. The debate is fierce, and it's playing out in real time on social media and in academic journals. But while the scientists argue over the cause, the effect is undeniable. 3I Atlas has shaken our certainty. It has forced us to look at the sky and ask, is that natural? In the next chapter, we will step back from the technical debate and look at the galactic context. What if the cargo this comet carries, those organic molecules, is part of a larger system? We will explore the theory of panspermia, the idea that life is hitchhiking across the galaxy, and we will see how the world, from the Kremlin to Twitter, is reacting to this silent departure. The science is fascinating, but the human reaction is just as telling. As we established, the object is leaving, but the ideas it has planted here on Earth are just beginning to take root. Is it a seed, a scout, or just a stone? The answer might lie not in what it is, but in what it leaves behind. Building on the intense debate over the origins of 3I Atlas, we must widen our lens. Whether this object is a derelict spacecraft or a strange rock, its presence in our solar system triggers profound questions about our place in the Milky Way. We are moving from the physics of the object to the metaphysics of its journey. This is the galactic context. In a speculative vein, what if these anomalies are signs of a galactic connection? We know the comet is shedding carbon dioxide, methanol, and complex organics. These are the precursors of life. The theory of panspermia suggests that life doesn't just spontaneously erupt on planets. It is seeded. It travels between stars on the backs of comets and asteroids, frozen in suspended animation, waiting for a warm ocean to land in. 3I Atlas could be an interstellar gardener. If it is carrying microorganisms, or even just the chemical blueprints for them, from its home system, it is effectively pollinating the galaxy. Its trajectory took it past Jupiter, Mars, Venus, and Earth. It dusted our neighborhood with material from a star system light years away. If it had impacted Earth, it could have delivered a biological payload. Instead, it just sprinkled us with possibilities. This connects to the idea of controlled motion that Avi Loeb hinted at. The comet's path was remarkably safe. It avoided the massive gravity wells that usually tear comets apart or fling them into the sun. It threaded the needle. In an even bolder version of the artificial hypothesis, one could ask, was this intentional? If you were sending a probe to scan a solar system or a canister to seed life, you wouldn't want it to crash. You would want it to do exactly what 3I Atlas did: fly by, sample the solar wind, release its cargo, and move on to the next star. The precision of the flyby has not gone unnoticed by the world's governments. While the scientists look at spectra, the defense agencies look at trajectories. NASA has launched its largest planetary defense exercises through January 2026, using 3I Atlas as a live-fire test object. They aren't shooting at it, but they are tracking it as if it were a threat. This is a dry run for the day a visitor arrives that isn't just passing through. The comet has become a training partner for our planetary shield, helping us refine the radar and laser tracking systems that guard Earth. The cultural reaction has been just as volatile as the comet's surface. At a press conference on December 19th, Russian President Vladimir Putin jokingly called the comet a secret weapon of Moscow. The room laughed, and he quickly dismissed the speculation, stating, It's just a comet from another galaxy, hundreds of millions of kilometers away from us. Our scientists know exactly what it is. But the joke landed with a thud in a world already on edge. It highlights how quickly celestial events get tangled in terrestrial politics. Meanwhile, the digital public square is buzzing. Social media platforms, including X, are awash with debates that mix science with mythology. The hashtag #BlueKachina is trending, referencing Hopi prophecies about a blue star that signals the end of an age. Users are posting grainy photos of the comet's blue-green coma, claiming it is the harbinger of a global shift. Others are analyzing the heartbeat data, convinced it is a Morse code message we haven't cracked yet. This is the human element of the story. We look at a ball of ice and metal, and we see a mirror. Some see a weapon, some see a god, some see a machine. The comet has become a Rorschach test for humanity's hopes and fears. But amidst the noise, there is a sobering reality. 3I Atlas is a reminder of how open our system is. We are not in a bubble. We are on a street corner in a busy galaxy, and traffic is whizzing by. Most of it is just dust and rocks, but the sheer strangeness of this visitor forces us to consider that we might be ignoring the more interesting traffic. So, what does this actually mean for the future? It means we need to be better at looking. We caught 3 Atlas on its way out. We missed the approach. If it had been an impactor, we would have had very little warning. The silent departure is a wake-up call. It tells us that the universe is vast, active, and full of things that don't follow our rules. As the comet speeds away, leaving behind a trail of mysteries, astronomers continue monitoring it from Earth, Mars, and Jupiter. The James Webb Space Telescope is currently slewing to track it, hoping to catch one last glimpse of that anti-tail in the infrared. This may be our last chance to unravel the secrets of another world before it fades into the deep black. In our final chapter, we will look at the race against time. The window is closing. We will discuss the desperate plans to launch an interceptor, the Project Lyra proposal, and the final verdict on what 3I Atlas leaves behind as a legacy. The visitor is leaving, but the chase is just beginning. Stay tuned. As we established in the previous chapters, 3I Atlas has challenged our science, sparked our imagination, and tested our defenses. But now the story shifts from discovery to departure. The final act of this interstellar drama is playing out in the cold darkness beyond Mars. The visitor is leaving, and it is taking its secrets with it. Time is running out. With every passing hour, the comet grows fainter. It is currently moving at a speed that puts it beyond the reach of conventional chemical rockets. It is already 270 million kilometers away, and the gap is widening by 58 kilometers every second. By the spring of 2026, it will be a ghost, difficult to observe, even with the most powerful eyes we have, like the James Webb Space Telescope. Scientists are frantically discussing the possibility of a chase. This is the realm of Project Lyra, a theoretical mission concept designed to intercept interstellar objects. The idea is to use a Jupiter gravity assist and advanced propulsion, perhaps nuclear, thermal, or solar sails, to catch up with the fleeing object. But the math is brutal. To catch 3I Atlas, a probe would need to be launched almost immediately and achieve velocities that push the limits of our engineering. The European Space Agency has a mission called Comet Interceptor, planned for 2029. It was designed exactly for this scenario, to park a satellite in space and wait for a long-period comet to appear, then ambush it. But 3I Atlas arrived too early. It slipped through the net before the trap was set. This missed opportunity is a bitter pill for the astronomical community. We had the technology, but not the timing. So, what does this actually mean for the legacy of 3I Atlas? It means that for now, we are left with the data we have. We have the heartbeat light curves. We have the spectra of nickel and methanol. We have the trajectory of the anti-tail. These are the puzzle pieces we will be assembling for years. Papers will be written, models will be run, and arguments will continue at conferences. But we may never get the smoking gun, a close-up photo of the nucleus. We won't see if it has a cratered surface or a smooth, metallic hull. We won't see the vents that caused the collimated jets. We are like detectives who found a fingerprint but missed the suspect. However, this is not a failure. It is a beginning. 3I Atlas, following in the wake of Oumuamua and the meteor IM-1, confirms that interstellar traffic is real and frequent. These aren't once-in-a-lifetime anomalies. They are a regular part of our galactic environment. We just weren't looking closely enough before. Now we are. The legacy of this visitor is the urgency it has instilled in us. The Vera C. Rubin Observatory, coming online soon, will scan the sky with unprecedented speed and depth. It will likely find dozens, perhaps hundreds, of these interstellar wanderers. The next time one enters our system, we will be ready. We will have the interceptors on the pad. We will have the protocols in place. As the comet speeds away, leaving behind a trail of mysteries, astronomers continue monitoring it from Earth, Mars, and Jupiter. This may be our last chance to unravel the secrets of another world, or simply a reminder of how vast and unpredictable the universe truly is. The heartbeat of 3A Atlas may be fading, but the signal it sent to humanity is loud and clear. We are not alone in the dark. The galaxy is reaching out to us, throwing stones at our window, waiting for us to come outside and look. If you enjoyed this deep dive into the mysteries of the cosmos and want to support science communication, please hit that like button. It helps the algorithm find other curious minds like yours. And don't forget to subscribe, because as strange as 3I Atlas was, the universe is infinite. Stay tuned. The next interstellar visitor may prove even more intriguing. This concludes our report on 3I Atlas. The file is closed, but the sky remains open.